Hey guys, welcome back. How are you? I hope you are good and doing well. So far, we discussed about bubble sort and in place and not in place sorting approach and how it works. Okay, now in this lecture, we will learn another simple and basic sorting technique, which is in place sorting technique by default, and that sorting technique is known as the selection sort. Okay, this is a very simplest and basic technique, sorting technique, just like bubble sort to understand the concept of sorting. Okay, and selection sort is a comparison based sorting algorithm. Just like bubble sort, it sorts an array by repeatedly selecting the smallest or largest element. If you want to sort the array in descending order, so it will be largest, and if you want to sort the array in ascending order, then it would be smallest. Okay, from the unsorted portion and swapping it with the first unsorted element. This process continues until the entire array is sorted. Okay, you can say that this is just like bubble sort, where we are moving the largest element at the end of each iteration, and here in selection sort, we need to move the smallest element at its correct position and after all required iterations, so we can get the sorted array. Okay, now let's discuss the selection sort in the steps that we need to operate on. So the first step is to find the smallest element and swap it with the first element. Okay, this way we get the smallest element its correct position. Then we find the smallest among remaining elements of the array. Okay, and then we swap it with the second element and so on. Okay, and the third step is that we need to iterate through or repeat these steps until we get all elements moved to the correct position. Okay, now let's implement the selection sort array in Ruby. Okay, so let me go to this class where we created the methods for bubble sort. Okay, so here we need to create a method, and the method name is selection sort, and here we need to accept the list as the argument, just like we are getting in the bubble sort. Okay, so here what we can do, that we can create a method and name it as like say def selection sort. Okay, and then accept the list as the argument. Okay, and one more thing that I want to tell you, that here in bubble sort example we saw how we can do in place sorting and in not in place sorting. So here I'm just going it the here the by default nature of the selection sort, which is in place. Okay, and if you wish, you can implement the not in place sorting as well, just like this example. Okay, so here we will just do the in place sorting. Okay, so selection sort list, and here. Okay, now, just like the bubble sort method, we need to define the length of the list explicitly. Okay, so what we can do here, n equal to list dot length. Okay, and then we need to iterate from the first to the last element. Okay, so we need a outer loop which is for first to last element. Okay, so for I in 0 to n minus 1. Okay, do. Okay, and now before executing the inner loop, what we need to do here, we need to define the index where we are considering the smallest element in the array or list exists. Okay, so let's suppose that this is the first element of the array, which is the minimum. Okay, so what we need to do here, we need to define the minimum index or the index of that smallest element. Okay, so what we can do, let's say minimum index is the I. Okay, because we are starting I from 0. Okay, so I is our minimum index here. Okay, now we need to implement an inner loop where we need to start with each element next to our assumed smallest element. Okay, so what we can do here, that for j in, and it should be start from 1 to or I plus 1 to n minus 1. Okay, or sorry, n. Okay, and here what you can do sorry, and here what you need to do, I plus 1. Okay, and then now we need to make a comparison to check whether the current element is smaller than our smallest element. I mean the first element of the array. If yes, then we need to set the portion of the smallest element with the position of current element. Okay, so here what we need to do, first make a comparison, that is if list of j is less than list of minimum index. Okay, minimum index, then what we need to do, we need to update the minimum index value, which is, let's say, at the minimum index we have the 59. Okay, and the first element is the 4, and 4 is less than 59. So what will be the minimum index now? Minimum index now will be the 1. Okay, so minimum index equal to j. Okay, save it. Now this is this inner loop will runs until we find the smallest element in the array. For example, here you can see it will go through entire element, and when it comes to 2 it will place it the first element, and however it will still look for the rest of the elements in the array. Okay, but since there is no smaller element in this array than 2, so it will just keep run, and no minimum index value will be changed. Okay, and now once the inner loop completed, then we need to swap the element, and we can do this using parallel assignment. Okay, so what we can do here, after this loop ends, here we need to do list of I comma list of minimum index. Minimum index is equal to list of minimum index comma list of I. Okay, so here what will happen, that this assignment will be done. I mean, the values will be swapped, or the smallest element will be moved to its correct position. Okay, now let's print the list. Okay, so here after the list I mean the swapping of the smallest element, what we can do, print list. Okay, and then just add a new line character here, so print slash n. Okay, and why we are doing, like, why we are printing the list and why we are printing the new line character, we are just doing this print to see the array state at the end of each iteration, and using this you can verify that after the end of each iteration the smallest element is placed on its correct position. Okay, and once everything is done, what you can do, that after the loop you just need to return the list. Okay, so save this. So this is the implementation of our selection sort. Okay, now what we need to do, that we need to try this method into the whether this is working or not, or whether this is sorting our array or not. Okay, so what we can do, rather than initializing the class, what we can simply do, that just copy this method. Okay, copy this method and go to the terminal, open the rails console. Sorry, we are already in the range console. So just to place this method here. Okay, and now let's find the array. Find this array and paste it here. Okay, now what we need to do, we need to call this selection method by passing this array. So selection sort and pass this array here. When you do this, you can see that we are getting the sorted array here, that is 2 3 4 4 4 6, and so the entire array has been sorted. And using this print you can see that at the end of each iteration we have the smallest element at its correct position. So in the first iteration what we have 2, so 2 is placed to its correct position, and then 3, then 4 4 6 34 56, and so on. So you can see that the list is changing over each iteration. That means our selection sort is working fine. Okay, so this is how selection sort works. Now let's discuss few things about the selection sort, that it has the complexity of order n for all best, average, and worst cases. Okay, because it doesn't matter whether the array is sorted or not, or whether swapping is required or not. Why? Because here we are considering any of one element, or let's say first element of the array as the smallest element, then we are comparing in each iteration it with the rest of the or remaining of the elements or within that array. Okay, and just because of this, this is not considered to be a standard sorting algorithm, and bubble sort is not also a standard algorithm, because if the list grows or the data set grows, it results in a very much time consuming approach. Okay, by the way, the simplicity of selection sort or the bubble sort make it more suitable to understand the basic concept of sorting techniques. Okay, so the time complexity for best, worst, and average case for the selection sort is order n square. And why order n square? Here you can see that we are running two loops. So this is the loop which runs for the n time. Okay, and for each element in this iteration, or this outer loop, there is an inner loop which is also running to the n time. Okay, so n cross n is n square here. So the time complexity of selection sort is n square, and the space complexity is order 1. Why? Because selection sort is by default and in place sorting. However, if you want to implement this selection sort just like a non in place sorting technique that we did here for the bubble sort, okay, so you can do that as well. But this is fine because the default behavior or the default nature of selection sort is the in place sorting technique. Okay, and that's all for this lecture. I hope you liked this and found this helpful. So thanks for watching this, and we will meet into the next lecture. Till then, tata, goodbye, take care, stay safe.